feasibility of fitting a 2-pole 15 amps disconnect under the heat pump's cover depends on the specific model and size of the new unit. It's advisable to consult the manufacturer's specifications or installation manual to determine the available space. Consider the following electrical requirements. The existing 2-pole 20 amp circuit breaker provides sufficient protection for the new heat pumps, as each unit draws 4.5 amps. Changing to a 15 amp circuit breaker would not be advisable. According to the National Electrical Code, a disconnect is required for each appliance with a motor that exceeds 1/8 horsepower. Since each heat pump has a motor, a disconnect is necessary. The new heat pumps require 15 amps fuses. A 2-pole 15 amps disconnect would meet this requirement. If there isn't sufficient space under the heat pump's cover, consider alternative installation options. Firstly, install the disconnect in a separate enclosure or location near the heat pump. Secondly, replace the existing cover with a larger one that provides more space for the disconnect. And thirdly, design and fabricate a custom mounting solution that fits the disconnect and the heat pump. It's recommended to contact the heat pump manufacturer to inquire about the available space under the cover. If there is insufficient space, discuss alternative installation options with a qualified electrician. Ensure that all electrical installations comply with the NEC and local codes. When dealing with electrical installations and heat pumps, several factors must be considered to ensure safety and compliance with electrical codes. The National Electrical Code, or NEC, plays a crucial role in defining the standards for electrical work. When addressing the replacement of existing heat pumps with new units that require specific electrical components, such as a 2-pole 15 amps disconnect, it's essential to understand the implications of these requirements and how they align with existing electrical infrastructure. Firstly, assessing the physical space available within the heat pump unit is a critical step. The manufacturer's specifications or installation manual are valuable resources for determining the dimensions and layout of the new heat pump model. If the available space under the cover is limited, it may not be feasible to install the 2-pole 15 amps disconnect directly within the unit. In such cases, alternative installation options must be explored. Secondly, branch circuit protection is a key electrical requirement to consider. In the scenario presented, the existing branch circuit is protected by a 2-pole 20 amp circuit breaker, and there are 3 units on the circuit, each drawing 4.5 amps. This configuration provides sufficient protection for the heat pumps, and changing to a 15 amp circuit breaker would not be advisable. The existing circuit breaker rating is adequate to handle the load of the heat pumps without posing a risk of overloading the circuit. Thirdly, the NEC mandates the use of a disconnect for appliances with motors that exceed 1/8 horsepower. Since each heat pump incorporates a motor, a disconnect is necessary to facilitate safe maintenance and servicing of the equipment. A disconnect allows for the isolation of the heat pump from the electrical supply, reducing the risk of electrical shock during maintenance activities. The new heat pumps require 15 amps fuses, and a 2-pole 15 amps disconnect would meet this requirement. This ensures that the disconnect is properly rated for the electrical load of the heat pump and provides a reliable means of disconnecting the unit from the power source. If the available space within the heat pump unit is insufficient to accommodate the disconnect, several alternative installation options can be considered. Firstly, a remote disconnect can be installed in a separate enclosure or location near the heat pump. This option provides flexibility in placement and allows for easier access to the disconnect for maintenance purposes. Secondly, the existing cover of the heat pump can be replaced with a larger one that provides more space for the disconnect. This solution maintains the disconnect within the unit while addressing the space constraint issue. And thirdly, a custom mounting solution can be designed and fabricated to fit the disconnect and the heat pump. This approach offers a tailored solution that maximizes space utilization and ensures a secure and compliant installation. To ensure a safe and compliant installation, it is recommended to contact the heat pump manufacturer to inquire about the available space under the cover. If there is insufficient space, discuss alternative installation options with a qualified electrician. A qualified electrician can assess the electrical requirements, evaluate the installation options, and ensure that all work complies with the NEC and local codes. In addition to these considerations, it's important to emphasize the significance of adhering to the NEC when performing electrical work. The NEC provides comprehensive guidelines for electrical installations, including requirements for wiring methods, overcurrent protection, grounding, and equipment installation. By following the NEC, electricians can ensure that electrical systems are installed safely and reliably. When replacing heat pumps, it's essential to conduct a thorough assessment of the existing electrical infrastructure and ensure that it meets the requirements of the new units. This includes evaluating the capacity of the branch circuit, the rating of the circuit breaker, and the availability of space for the disconnect. If any upgrades or modifications are necessary, they should be performed by a qualified electrician in accordance with the NEC and local codes. Furthermore, proper grounding of electrical equipment is crucial for safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. All heat pumps should be properly grounded in accordance with the NEC, and grounding connections should be inspected regularly to ensure their integrity. Overcurrent protection is another critical aspect of electrical safety. Circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. The correct size and type of overcurrent protection devices should be selected for each circuit to ensure that they will effectively protect against electrical hazards. Regular inspection and maintenance of electrical equipment are also essential for preventing electrical problems. Heat pumps should be inspected periodically for signs of wear and tear, such as damaged wiring, loose connections, or corroded components. Any issues should be addressed promptly to prevent them from escalating into more serious problems. In addition to these technical considerations, it's important to emphasize the importance of safety when working with electricity. Electricity can be dangerous if not handled properly, and it's essential to follow all safety precautions to prevent electrical shock and other injuries. Only qualified electricians should perform electrical work, and all work should be done in accordance with the NEC and local codes. When working on electrical equipment, always energize the circuit by turning off the circuit breaker or removing the fuse. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical equipment in wet or damp conditions, and always be aware of your surroundings to avoid potential hazards. By following these safety precautions, you can minimize the risk of electrical accidents and ensure that electrical work is performed safely and reliably. In conclusion, replacing heat pumps requires careful consideration of electrical requirements, space constraints, and safety regulations. By consulting manufacturer specifications, adhering to the NEC, and working with a qualified electrician, you can ensure that the installation is performed safely and in compliance with all applicable codes and standards. Remember, safety should always be the top priority when working with electricity.